where decisions are made.
It doesn't want to go. There we go. So question number 4, if I pass one that you think you want to talk about, let's do it. So this was inverse. I think we've got inverse. First one was slope. Slope, how are we feeling about slope from yesterday? We good on slope? Sometimes it's just a matter of brushing off cobwebs. Good morning. Oh, Addie, I thought Addie was already in here. Yeah, we can go back to one of the slope ones I see in the chat. So here, question number 4. Line segment MN has a midpoint of A. So if I have M and I have N, I've got a midpoint of A. That's an M, by the way. It doesn't look very much like an M. I'll make it more. Yeah. Midpoint of A has an endpoint of -9.6 and a midpoint. So I've got an endpoint and a midpoint. I'm looking for the other endpoint. So I want to make that chart, right? -9.6 and -1. -6, how do I go from -9 to -1 on a number line? +8. So if I add 8 to get to -1, I add 8 more and I get to 7. I think there's only one. Oh, no, there's 2 answer choices that have a 7, so I can eliminate those 2. But I do have to go over here. How do I go from 6 to -6? -12. So if I -12 more, I'm going to get to -18. So we just got to follow that pattern. -12 + 8, and that is that. The struggle is real for a couple people getting in. Zoom keeps kicking them out. Like they're trying to come in and they get kicked out. All right. So that was number 4. Yeah, Lily. Yeah, absolutely. So go to number 5. That was length. So we got to do distance on this one. And then question number 6. Question number 6 was a good one to look at. So 4 and 8, let me see if I can zoom in on this a little bit. 4 and 8, these lines are parallel, right? So they're on opposite sides of the transversal. The transversal connects the 2 dots. So I've got 4 and 8 are alternate. So that's going to be alternate interior. Alternate interior. And then 3 and 8, let me grab a different color. Maybe. Come on now. Bless you. 3 and 8. 3 and 8. I can take this northeast corner and I can slide it down the transversal and it still lands on that northeast corner. These are corresponding. And we're going to talk about these today. So hopefully that helps. And then if we go, yeah, 3 and 12, we're going to do that now too. I was just grabbing a different color. So because they all go with 3. So it can get a little confusing. So then oh no, that's not 3. This is 3, isn't it? 3 and 12. So 3 and 12 are on the same side of that transversal, but they're outside the parallel lines. So if you imagine these are the parallel lines, 3 and 12 are on the same side of the transversal, but outside the parallel lines. So that same side exterior. Does that help a little bit? So you're always thinking same side or alternate of the transversal, and the transversal, there's always one of them that connects the 2 dots, the 2 angles. And then interior, exterior with the parallel lines, the parallel lines, there's 2 of them. So let's go look at question 7. Solve for the variables. Okay, so this was like the discussion post from Monday. And if you're still confused on these, we'll practice a lot more of these today. So this is my transversal. These are my parallel lines, even though they're not marked. Sometimes we get lazy and they're not marked. If I take these two purple angles, see how it kind of makes a C or a U? I've got one acute angle and one obtuse angle. They're going to equal 180. So same side is always supplementary. I'm going to add those two angles together and set them equal to 180. And then you're going to solve. Subtract 84, divide by 6, and you get x. Okay? So if you solve this equation, you're going to get x. If we come over here, and we use this angle and this angle, what's their relationship? They do equal each other. These guys are corresponding. I can take this northwest corner, I can slide it down the transversal, and it lands right on this northwest corner. So those are going to be congruent. They're both obtuse angles. So I'm going to set those equal to each other. Once you get that answer, you'll have y. Okay? Take them one step at a time. If this wasn't a whole number, we'd have to do whichever pair had the x's in it first, or whichever pair had the same variable. Is a more accurate statement. So let's go back to one of the slope questions, because somebody had a question about the slope. Bless you. This one's length, that's distance. Remember, length and distance are the same thing. They're synonyms here in geometry. We've got slope here. So if it's slope from a graph, and actually this has the points and the graph, so it doesn't matter which one you do. I personally prefer the graph. I always start at the left point, and I'm going to go up 1, 2, 3, so that I'm at the same level as this other point. So up 3 is positive 3. And then I'm going to go right. 1, 2, 3, 4, 5, 6, 7. So if I go right 7, and I'm counting those jumps, not the spaces. So it's like 1 jump, 2 jump, 3 jump, 4 jump, all the way to 7. So it's rise over run. So we're going to do 3 over 7 is going to be our answer. Now, if you get kind of lost in the graph, and some people do, and you want to use the ordered pairs, you can do that. You want to start with the y's. And it doesn't matter which one you start with, -4 or -1. I'm going to start with the -1 because that's going to give me a positive number. So -1 minus -4. Sometimes that's where people get messed up. When you subtract a negative, you can put those negatives together and make them a positive. So that y value is 3, which is what we got right here. And then I take the x's, -4 and +3, because I started with the 1, the 3 has to go under it. So these two numbers are an ordered pair with the y on the top and the x on the bottom. The y on the top and the x on the bottom, which means the -4 and the -4 have to go together. Remember, this was a -4 before we subtracted it. So we're going to subtract -4. And again, when you subtract a negative, that's really positive. So that gives me 7. And that's my 7 from the graph. And again, if you're still stuck on this, the best way to practice it is with that E2 IXL. Okay. Any other questions we want to talk about the homework? Kind of looking in the chat. All right. Then let's go back into today's folder. So day 4, we're going to try something new. I've never tried to add a new slide to the digital notebook, but I found this yesterday and I thought it would help a lot of folks who are still struggling with some of those angle relationships. We've got to have those angle relationships down before we can move on today. So I know it's kind of hard to see, but there is a link right here under the word link. If you click on that, it'll force you to make a copy. Oh no. Let's see if we can fix that.
You want us to put this on the...
And I do. Once you open it up, I want you to put it on, add it to your, did that help, Mason? Do you have access now?
How do you do that?
Well, let's try a different way. Why are you just buffering? Come on now. My computer is thinking about something. My mouse is just spinning. I was going to try to put it in the chat. I shared it. I'm just not sure I shared the right copy. What do you mean? Well, I got the link from up here. I just can't add it because the Zoom, I think I'm zooming out. Do you guys still see me on Zoom? I think Zoom died is the problem. We'll get back online. It says I'm still joined. I have no idea what it is doing. All right. What lucky winner in Zoom was made host while my Zoom was crazy? Am I muted? My windows are like firing like electrons. Come on now. All right. We're going to put the link to the slide in the chat. Hopefully it will ask you to make a copy. Here we go. If you click on the link in the chat, does it come up? Awesome. So now let me try to fix it for the folks that are not in Zoom. There we go. We'll fix it here too. Maybe. Come on, little laggy computer. Wow. We're not going to get very far if there's a 60-second delay every single click. All right. The link in the Schoology page and the link in the chat should both be good. Does everybody have a copy of the slide? It still says you need access? Yeah, I think that's probably the fastest way. If you refresh your screen, does it help in Schoology? Refresh the page in Schoology. So everybody has it now? Say it again. Yeah, it's still the link. I just updated it. It doesn't work even after you refresh. Refresh the page and see.
It works. I went out and I refreshed.
Yeah, it's no.
Now, how do you add this to the other one?
So what you can do is come over here, right click on the, like the slide over here, or you can even, mine's just buffering, and hit copy. And then open up your digital notebook. You can put it wherever you want to put it, actually. It's just one slide. That's all it is. And my computer, maybe if I click Screencastify, that will help. But then it didn't close. Technology guy sent out a thing the other day saying, if your technology is not working, just figure out how to do virtual class without technology. I was like, yeah, that's not super helpful. Not super helpful at all.
The school Wi-Fi.
It is the school Wi-Fi. It's under a great deal of stress. It should be though. And they've had a year to upgrade. Exactly. That's what I'm saying. Right, right. Oh my God. What?
Only you.
It's only me? Well, that's good to know. It's like not even letting me, I think Screencastify is the problem. It shouldn't be, but I think it is.
Either that or is the hosting again.
Maybe. Okay. Let's, like my Schoology is just spinning, everything is spinning. This can close. All right. If we take this slide, it's like not letting me do anything. I'm just going to stop touching it for a minute. Take this slide, you guys all have a copy, and sort the angles. Like, where do the angles need to go? They will kind of overlap each other. Yes, they will.
It doesn't matter, like, because there's multiple verticals.
So you shouldn't have to reorient them at all. They should all fit. And if they're in the right spots, they'll be like on top of each other with the small one on top of the big one. Let's see if it figured itself out now.
Oh, that makes sense. No, there's multiple verticals.
Exactly. So not everyone will put them in exactly the same spot, but they should all fit. How about this one here? What lines can I prove parallel and why?
You could prove the 115.
I've got 65s and I've got 115s. So Jacob, you're saying I've got this 115 and this 115. What do they prove parallel? They are alternate exteriors, so they're connected by a transversal. They're in two separate intersections. They have a valid pattern. So P is parallel to R. So we can write P is parallel to R because alternate exterior angles. Anybody else see another pair that we can do? What are those 65s? Tell us. They are corresponding. So the 65 can slide down onto the 65, which means P and Q are parallel. P and Q are parallel because of corresponding. Okay. So always look for those valid relationships. When we go to practice, you're going to circle the things that are congruent and circle the things that are supplementary. Do we need another minute with that, or are we good? Alternate exterior. So these are alternate sides of the transversal and exterior to all the parallel lines. Alternate exterior. Good question. If I ever abbreviate anything, write anything that's not clear, call me out on it. What? Oh, no. Thank you. What? For this one? The one below? This one? The first one, the boats? This one? So we said that they were congruent and corresponding, so the lines are parallel. Congruent and corresponding, so the lines are parallel. What about this one? This one's asked a little bit differently. So talk me through some thoughts here. If I know L and M are parallel, we've got these marks, right? And I know 1 and 3 are congruent. So I can put in those congruent marks. Those little loops mean they're congruent. How can I prove P is parallel to R? I want P and R to be parallel. What do I need to know? Kind of hinges on 2. What do I need to know about 2? Exactly. So if P and R are going to be parallel, then 2 has to be congruent to 1 because they're corresponding. And 2 has to be what with 3 because they're alternate exterior. What symbol do I have to put in here? 2 and 3, are they congruent or are they, why are they congruent? Because they're alternate exterior. Okay, so sometimes it'll say, what do you need to know? And here, the need to know is that 2 has to be congruent to 1 because they have to be corresponding, and then 2 has to be congruent to 3 because they're alternate exterior. And that would prove that P and R are parallel. Okay. This is where we're going to try Zoom Bomb. I don't know if it'll work, but I want you to try to give me an example of a pair of supplementary angles that will prove A and B parallel. So if I'm trying to prove A and B parallel, A and B, what's one example of a pair of supplementary angles that will do it? And if you're on Zoom, what I want you to do is write it in, but don't hit enter. In about 20 seconds, after everybody's written in an example, like 1 plus 10 equals 180, write in your example. We're all going to hit enter at the same time. And Zoom is just going to go, and hopefully not crash. Okay? I hope not. Okay? So, does everybody have their answer? Mine is going to be 1 plus 10 equals 180. That's going to show that A and B are parallel. 1 plus 10, 1 plus 10 equals 180. See if you can come up with a different example to prove A and B parallel.
Did you do 1 plus 9?
Is 1 plus 9 going to be 180? Or does 1 have to equal each other, 1 and 9? Let's see what we end up with. On 3, everybody's going to hit enter at the same time. Ready? 1, 2, 3. 8 and 15. 8 and 15. 8 and 15, I love it. 2 and 9, I love it. 5 and 14, perfect. 2 and 3. 2 and 3 are in the same intersection, so that one's not going to work. 4 and 12 are going to be congruent, so 4 equals 12 could go down here in this one. What else do I see up here? 5 and 14, 100%. So we could do 5 plus 14. In this yellow box over here, I want you to write 2 examples that show supplementary angles proving A and B are parallel. So we can do 1 and 10. We can do 4 and 11. We can do 5 and 14. We can do 8 and 15. Or we could do any of the same side interiors. Basically, for supplementary angles, they've got to be same side.
Did you do 10 equals 14?
10 equals 14. So 10 and 14 are on B. Those are going to prove N and M. So let's hold off on that one for a minute. Yeah, exactly. So we're just trying to prove A and B are parallel. So we need one on A and one on B, and they equal 180. Now let's do the same thing, but with congruent angles. Okay, so what pair of angles can you put to equal each other that will prove A and B are parallel? So remember, you need one on A and one on B, and they've got to be congruent. And there are so many examples for this. Ready? In 10, 9, 8, 7, 6, 5, 4, 3, 2, hit enter. 3 and 11, 2 and 10, absolutely. What else we got? 1 and 5, 100%. So 2 equals 10, 3 equals 11, 3 and 7. 3 and 7 are going to prove N and M parallel because 3 is here and 7 is here. It's traveling on A. So you've got to be traveling on one of these transversals between the two lines. You need one on the A and one on the B. Yeah. 5 and 13, absolutely. 5 and 13 would be perfect. 5 equals 13. So we've got to have one angle on each of the blue lines, and they've got to be congruent. So we could do 7 and 15. We could do 9 and 3. 9 and 3 would be a good one. 9 equals 3. So we can do corresponding or alternate, and we can do alternate interior or alternate exterior. The trick is you've got to have one angle on each of those blue lines. Okay? So now let's erase all of this, and let's think about, everybody should have 2 examples, by the way. Does everybody have 2 examples?
What
do you mean?
The question is the same thing.
Oh, it shouldn't be, because that's a typo. This should be supplementary. Let's change that. Change that to supplementary. So now if I want M and N to be parallel, I need one angle on each of those pink lines, and they've got to be traveling on either A or B. So what's one example of a supplementary pair that will prove M and N parallel? So maybe you do 2 and 7. 2 plus 7 equals 180. So in the chat, you choose one. I'm going to write 2 plus 7 equals 180. What's your pair going to be? Remember, we need one on an M intersection and one on an N intersection. One on an M intersection and one on an N intersection. And they have to be connected. You ready to hit enter? Ready? 5, 4, 3, 2, 1. Let's see if we can crash Zoom. Boom, 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 boom. So 9 and 13, I love it. 9 and 13 are going to be congruent, however. So 9 and 13 are going to be congruent. So 9 equals 13 because those are corresponding. And then 10 plus 15, I love it. 10 plus 15 would work beautifully. 10 plus 15 equals 180. And then what else do I see? I saw a lot of 10 and 15s. 9 and 16. 9 and 16. Awesome sauce. Yes. 9 and 16. Okay. Last one. Which ones are congruent pairs that will prove M and N parallel? Congruent pairs. Give me another pair of congruent angles. What can we do? Type it in the chat. And then in 5, 4, 3, 2, 1, go. 2 equals 6. 16 equals 12. 3 equals 13. I love it. So 3 equals 13. Ooh, are those connected? 3 and 13? They're not. I can do 3 and 7. 3 and 7 definitely work. They've got to be connected on a transversal. And then 16 and 12. 16 and 12. That is fantastic. Those are corresponding. 1 and 7. 1 and 7 for sure. Alternate exterior. And then 7 and 3. And then 7 and 3 we found. So be careful. You can't go diagonally through the center of the square. Like if you think of this as like a big, like our courtyard, we can't go from the auditorium over to the EBA hallway. We can't go from the gym over to the cafeteria. You've got to go around a corner, right? We can't go through the courtyard. Not allowed right now. So they've got to be connected on a single transversal. You can't go through the middle. Let's see what other practice we have here. Either open the Pear Deck or the Google Slides. It doesn't matter to me which one you open. I'm going to open the Pear Deck, and I want to kind of do the same thing. So which lines can you prove and why? And I'd like for you to put them in the chat. So think for a second, look at these angles. Remember that they are going, all of these mean they're congruent. And there's a couple of different correct choices here, and I want to talk through them. Which angles are connecting two intersections, have a true relationship, they should be congruent and they're marked congruent, and which lines are then parallel? So in the chat, write which two lines you think are parallel. And I'm going to put them in the chat too. Everybody got an answer? And on 3, we're going to go 1, 2, 3. A and G, L and F, A and G, L and F. I like it. So A and G have alternate exterior angles for sure. And then L and F. The problem with L and F is this. Let me get another color so it's like more clear. L and F, these angles are only going to be congruent if they're 90 degrees. Because they're same side of A. They're both on the north side of A, so they have to be supplementary. If they were marked with right angle boxes, we could say L and F are parallel. Because they're only marked congruent, and this is the tricky part. Because they're only marked congruent, we can't say that. Okay, so if you're on a Pear Deck, please write that in. Probably only A and G are going to be parallel. Okay, let's look at another example. Oh, somebody said A and S. A and S. So I can't use either of these two angles to get to S. And these are the same problem. They're same sides. So the same side should equal 180. So if they were marked with right angle boxes, then we could 100% say A and S are parallel. But because they're not marked with right angle boxes, we can't do that. Okay. And these take a lot of time. They're so confusing. So let's circle some congruent or supplementary angles. So find some angle pairs that are congruent or supplementary. Take a second to do that. The only ones that I see that are congruent are these 60s myself. These two don't have a relationship, but do these have a relationship? They're connected on transversal K. So transversal K is here, right? Which means if I've got parallel lines, it's going to be I and M. So if you kind of turn your head, this is the transversal. These are going to be the parallel lines. What's this relationship between 60 and 60? Alternate interior, yes. And are alternate interior angles congruent? C. So I is parallel to M.
Supplementary, the two other six, so in the triangle, the 260, wouldn't those be supplementary?
Supplementary adds up to 180.
But our same side interior angles are supplementary.
So same side interior angles would have to be 180, and these are only 120.
Oh, okay.
We could use this 60 and this 120, maybe. I'm not sure that works either. Although if we want to be really, like, there are some things where we know all of those are 60, and then we could conceivably say this 60 and this 120 make E and Y parallel, but that's like extra. We haven't gotten there yet. Okay. So because the triangle adds up to 180, this angle is 60. And because the straight line adds up to 180, this one is 60. All of these angles are 60. Now I've got same side exterior angles that add up to 180. But that's extra. I won't test you on that this unit. Okay, let's do a couple more. I know we're running out of time, and I do want to give you some practice. How about these? Do these angles prove anything? Are they connected by a transversal? Can I go from this angle to this angle in one straight shot?
No.
I cannot. So these are not connected. They can't tell me anything. Okay.
You can go from the top one to the bottom.
Can I go from the top one to the bottom one or the middle one to the bottom one? Yeah, so we can use this angle and this angle. What's their relationship? Alternate exterior. Alternate exterior should be congruent, and they are. So R is parallel to C. Okay? Is it kind of making sense a little bit? It just takes some practice, and these are tough. It's, I think, the toughest thing in this unit is this kind of stuff. So let's do one more. Think about this for a second. I'm going to give you 60 seconds of think time. And it's okay to say yes, sorry, nope. It takes a minute. Take a look at these. If I have angle 1, angle 2, and angle 3, which two angles should I look at? Which one can I throw out because it's not connected? Which one is not part of a pair that's connected to anything with a single line? Which angle can I throw out? 1, 2, or 3? Couple people say 2, couple people say 3. Defend yourself. Is 3 connected to anything? If I'm at 3, whose house can I go to and stay on one street? My mom's rule is you can cross intersections, but you can only be on one street.
You go to one.
So I can go to 1's house. If I'm at 3, I can go straight up this R street to 1. Okay? I can't go over to 2. Sorry, that makes me turn a corner. Mom says I can't do that. If I'm standing at 1, whose house can I go to? I can go down to 3. I can't go over to 2. They're not connected by a transversal. So I can throw out 2. Can't use 2 because it's not connected. Do 1 and 3 have a relationship? Corresponding. Are corresponding angles supposed to be congruent? Yes. because they're congruent, because they're connected, because they're corresponding, I can say E is parallel to T. Okay, should we do one more? Okay, we can do as many as you guys want to. Which two angles are congruent? Always look for those congruent angles first. Which numbers are exactly the same? I see a 54 and a 54, absolutely. So let's start there. Always start with the easiest stuff. Do they have a relationship? Are they connected? Yeah, they're connected. They're connected on this transversal. Let's label that A. So it's transversal A that connects them. So what lines are parallel? K and Y. So if you highlight those angles, right? If you highlight those angles, and then you highlight the transversal, A is my transversal, it's the other two lines that are parallel. So K is parallel to Y. Are there any that are supplementary?
Can do the math on 54 and 126.
54 and 126. Does this 54 and 126 tell us anything?
Oh, not that one, just the one above.
Ah, so I can look at that. Why doesn't this one tell us anything? Well, they're a linear pair. They're not in different intersections, right? We got to have a different center. I like that thought. Okay, so but I could look at this 126 and this 54. You can always do the vertical angles. So if this is 54, I can always put a 54 here. Vertical angles are always true. So then what's the relationship between these orange angles over here? Same side interior. See how all those angle relationships from the GIMP kit are so important? If I kind of highlight those lines, then this just underscores that Q is parallel, or K is parallel to Y. Okay. We want to try some practice. Let's try some practice together. Do you want to open the homework or the quiz? Which one do you want to start together? The quiz? Okay. So everybody go to the quiz. Let's open that. Hopefully nobody started it, because if I click on here, it's going to show somebody's answers. Have you already started it? Okay. Oh, but you haven't submitted anything, so I'm not ratting you out. That's all right. It's all good. It's all good. Okay, so let's talk through some of these to make sure we're all on the same page. And then you've got the homework and the quiz to do tonight. Which pair is not supplementary? So if I look at 3 and 5, are those supplementary?
Yes.
They're same side interior, so they're going to be supplementary. How about 1 and 7? 1 and 7, are they supplementary? Yeah, because those are same side exterior. How about 1 and 2?
Yes, they're a linear pair.
They're a linear pair. They make a straight line, so they're not going to prove anything parallel, but they are supplementary. They're a linear pair. So 1 and 8 must be 1 and 8 are congruent. So that is our answer. Okay. And I'm kind of going through these to give you an example of how to think through them. Which pair is not congruent? Take a second, look at them. See if you can figure out which ones are not congruent. Anybody come up with an answer? My handwriting's getting big. 2 and 8, absolutely. Why are 2 and 8 not congruent?
Because
They have no relationship?
No, they're not corresponding right now.
They're not corresponding. They're not alternate exterior. They're same side. And if you think about the size, like that whole reason we put that Google slide in, is I've got an acute angle up here and an obtuse angle down here. They're different sizes. They're not going to be congruent. What about 10 and 12? 10 and 12, what's their relationship? M is the transversal. So J and K are the parallel lines. What's the relationship there? If I've got a corresponding, absolutely. I've got a southwest corner and a southwest corner. Those can slide down on top of each other. Okay. So those are corresponding. How about question 4, 17 and 14? 17 and 14. I like the alternate. They're connected by J, so that's the transversal. They're definitely alternate, so they're not same side and they're not corresponding. Are they inside or outside these parallel lines of M and N? Inside. So alternate interior. Okay. And what we're really practicing here, I don't think you'll ever use these words in real life. What we're practicing is just like kind of logical thought and breaking down the problem. How do I set up these equations? If I've got this obtuse angle and this obtuse angle, how are they going to be related? They are supplementary. Are they supplementary? I've got a southwest corner and a southwest corner. They're both obtuse.
So they equal 180.
So they equal 180? Why are they congruent? They're corresponding. So they are same side, and that's where we get kind of messed up. They're on the same side. One's interior and one's exterior. They're both obtuse. If you like take your hand and you go, okay, that's an obtuse angle and it can slide down and that's still the same obtuse angle, these guys have to be congruent. So we've got to set them equal to each other. So on a piece of paper, 8x plus 20 equals 11x minus 31. I always subtract my variables. So minus 8x. (11x minus 8x is 3x. If I move my variables to the right, I move my numbers to the left. It does not. This is just the way I do it. And then you got to divide. 51 divided by 3x. Yeah, Lily. Yep. So they're alternate interior because they're inside the parallel lines and alternate of the transversal. Okay. It is 17. How about these guys? Are these going to be the same or are they going to be supplementary? They are going to be supplementary. Why are they supplementary in question 6? Because they're not corresponding. They're same size. Okay. Same side, same size. Or same side, supplementary. So these you're going to add up to 180. So if you're writing some notes for yourself, set those equal to 180. I have one acute angle and one obtuse angle. Okay. Question 7, how are we going to set these up? If they're alternate exterior, they're both acute. Are they going to equal each other or equal 180? Each other. So these two are going to be equal. So in 6, we're going to set them equal to 180 because I have one small and one big. They're same side equals 180. And then in 7, they're going to equal each other because they're both acute. Number 8 is really the one that I'm rushing to look at. So if you're already packing up, I feel you. I know the bell is going to ring soon. I've got an obtuse angle here, and then together these two make an obtuse angle. So this one angle corresponds to these two angles. We've not done one like this. So we're going to do 2x plus 13. That's my obtuse angle over here on the left, equals 47 plus 72. So if you haven't written yourself any notes yet, this is what you want to do. Write yourself a note. This one obtuse corresponding angle adds up to or equals these two corresponding angles. Okay? And then 9 and 10 and 11. You should be good for the rest of them, I think. But we'll talk about them tomorrow, okay? So just to wrap up, finish this quiz, last 3 questions, and then make sure you do the homework. And I'll see you guys tomorrow.